A review for the computation of the equivalent weight and the milli-equivalent weight. Yung sa molecular weight, I believe you know this very well. And I don't think I need to give you a review on that. But for the F, plus remember the F is dependent on what type of compound is given. So you have to make sure that you can correctly identify whether the compound is an acid, a base, or a salt. So tatlo lang yan sila. Now, according to the Arrhenius theory, when you say acid, you have the hydrogen. So you just have to count the hydrogen that is replaceable for an acid for you to know the F. So just like hydrochloric acid, and then we have the nitric acid, sulfuric acid, perchloric acid. Just count the hydrogen there, and that will be automatically the F. Okay, we only have few exceptions here. The exceptions will be on the organic acids. Kasi ito yung mga binigay ko sa inyo. These are inorganic acids. They don't have carbon in their chemical formula. And then automatically, you just have to count the number of hydrogen. But in the case of the organic acids, just like the acetic acid, the acid found in our vinegar, you can see 4 acids here, but actually this is the only replaceable acid for the acetic acid. So just take note that for acetic acid, the F is 1. Okay, so yan lang yung kanyang replaceable hydrogen. Hindi kasi mag-completely dissociate si organic acid. That is the reason why this is called weak acid. It will not really give all the hydrogen that it has. Isa lang ang ibibigay niya. Ito kasi ibibigay na ito lahat, kaya counted sila as factor for equivalence. Now, for the base, again, according to the Arrhenius theory of acids and bases, when you say base, there is the presence of hydroxide. So you just have to count also how many hydroxides are present in the compound. And most likely, you will identify them using the subscript. So just like sodium hydroxide, we only have automatic 1 here. But if it is written inside an open and closed parenthesis, just like in the case of calcium hydroxide, the F is 2. Okay? Ito yung subscript niya. So automatic, meaning yan, 2 hydroxide. Another example is the aluminum hydroxide. Again, the hydroxide is placed inside an open and closed parenthesis, and it has a subscript of 3. So automatic, the F is 3. Kasi it means that it has 3 hydroxide molecules. Okay, so that's the case of acid and base. Yes, question?
Si ferric hydroxide, ma'am.
Ferric hydroxide?
Si ferric, ma'am. 2 ba ang ano?
Okay.
ON niya?
Ferric, remember ferric is iron. Tapos pag nag-end siya sa IC, I hope you can still remember this. Pag nag-end sa IC yung name, it means it has the larger oxidation state. Pero pag nag-end siya sa OUS, just like the ferrous, ito yung lower oxidation state. Now, in the case of iron, it can be +2 or +3. So, kung ferric yan siya, +3 si iron, hydroxide mo, -1, kailangan kang mag-criss-cross dyan. The correct chemical formula of ferric hydroxide is FeOH3. So, if you are asked to identify the equivalence factor for ferric hydroxide, this is 3. Okay? Anything else? Wala na?
Okay na, ma'am.
Ang tandaan ninyo ha, I think sa video, I gave a review there of the charges of the elements. Just be familiar with their arrangement in the periodic table, most likely the group number will be their charge. The transition metals, the metals in the center, most of them are +2. However, we have exceptions because we have transition metals that have 2 oxidation states. So okay lang sana kung systematic name ang sinulat like this, iron 2 hydroxide. Okay lang sana kung ganito. Kasi you will know that iron is +2, and if you are going to make the chemical formula, sorry, this is -1, you have to do the crisscross. You will see there that FeOH2 yung kanyang tamang chemical formula. This is the systematic formula, ha? Pero pag common name ang ginamit, ito yung ginagamit natin, yung nag-e-end sa IC and OUS. So do not forget that if the name of the element ends with IC, it means it will have the larger oxidation state. And then the OUS will have the lower oxidation state. Okay? Oh, that is wrong. Ferric hydroxide is FeOH3. If it is FeOH2, that is called ferrous hydroxide. Okay? So just like ferrous sulfate na ginagamit natin for as supplement for iron deficiency anemia, those persons with an anemia class, ferrous sulfate yan siya. Ferrous sulfate is, since this is OUS, that's +2, and sulfate is -2, you don't need to do the crisscross. So the correct chemical formula here is just FeSO4. So that's not the case for the ferric sulfate. The ferric salts are actually considered as toxic. So we don't really consume them internally. So kaya kailangan alam nyo talaga yung difference ni ferrous and ni ferric. Yung ferrous yung ginagamit natin as supplement or yung para sa body natin. Kasi pag naging ferric yan siya, magiging toxic na yan. Okay? So kung ferric yan siya class, IC means it will have the higher oxidation state, that's +3, and then sulfate is still -2. This time, since hindi siya mag-i-equal sa 0 just like this, pag mag-equal siya sa 0 pag i-add natin, automatic, ito na. Pero pag hindi yan mag-equal to 0 kung i-add, that's the time you do the crisscross. Therefore, for ferric sulfate, this is the correct chemical formula. Okay? Anything else? Nabaliktad. Dili siya dapat mabaliktad. Kaya pag sinabing OH, pag sinabing hydroxide, OH talaga yan siya. And hindi yan siya nagbabago. 3. Kung sa molecular mass, if you have this formula FeOH3, pag nag-compute kayo ng molecular formula, Fe is 1 atom, oxygen is 3 atoms, and hydrogen is 3 atoms. Kasi this is placed inside the parentheses and you have the subscript, meaning you have to distribute this 3 for the both of them. So 3 atoms yan sila, dalawa, i-multiply natin sila sa kanilang atomic weights that are rounded off to the nearest whole number. Okay? Ang aluminum oxide, what about the aluminum oxide? What's the problem with aluminum oxide? Aluminum oxide. Plus, when you are going to write the chemical formula, the first step is to just write the symbols of each element or element plus polyatomic ion, and then identify their charges. Aluminum is found in group number 3 in the periodic table, so that's +3. And then oxygen is in group 6 group 6, which means negative 2 siya. Now, if you add the positive and the negative charge, if it is equal to 0, then that's it na. You just have to combine both symbols. But if it is not equal to 0, just like this, positive 3 plus negative 2 is positive 1. That's the time plus you do the crisscross. And this will be the correct chemical formula of our aluminum oxide. Now, if you are asked to identify the equivalence factor for this, for you to compute the equivalent and the milli equivalent weight, take note, aluminum is positive 3, oxygen is negative 2. Hindi yan sila pantay. And that's the time you multiply them with their subscript. So 2 times positive 3 is positive 6. 3 times negative 2 is negative 6. Ayan, pantay na sila. And that will be the F for aluminum oxide. Okay? I hope na nakuha yon. Paano, ma'am, if 2 ang charges? What do you mean 2 ang charges?
For example, ma'am, na ay positive 2 tapos positive 4, ana, good, ma'am? Kung saan gayahon, ma'am?
Positive 2 niya na ay positive 4. Can you give me an example?
Example, ma'am, is ang chlorine, ma'am. So, charge kay positive 1 tapos positive 5.
Magiging positive 5 lang yan si chlorine if most of the time nasa oxoacid siya. Like HClO4. Ayan. Kapag hindi siya sa gitna, again, if hindi nasa gitna si chlorine, yung charge niya, negative 1 talaga yan siya. Again, negative 1. Please do not look at the charges or the oxidation states given in the periodic table. Kasi yung mga nakalagay dyan, baka malito kayo na ingon ni ma'am pag nasa group 1, positive 1. Pero naalagi mga elements din na daghan og ka ng oxidation state nga nakabutang. Look at your periodic table. Just like chlorine, kung binigay man dyan sa periodic table nyo or if even if mag-google kayo class, marami siyang ibibigay na oxidation state. Kasi yes, these oxidation states really exist, but depende yon siya sa compound. Okay? Pag ano siya, like sa chlorine, ganito. Si chlorine, pag it is combined with an element, example, this element is positively charged and then you have chlorine here, automatic negative 1 talaga yan siya. Pero pag si chlorine class is involved in a compound na maraming atoms, just like this one, hindi lang dalawa, tatlo sila, hydrogen, chlorine, and oxygen. Tapos si chlorine is hindi nasa huli, nasa gitna siya. Yan yung time na magbabago yung kanyang oxidation state. It will not be negative 1. Okay? So, pero hindi mo ito gagamitin, magiging positive. Let me check kung ano yung kanyang charge here. Pag mag-check ganin mo ang charge anang element nga na sa tunga, this is how you are going to do it. Hydrogen, you have hydrogen, chlorine, and 4 na oxygen. Ang gagawin nyo lang is identify how many atom, hydrogen isa, tapos yung charge ni hydrogen, wait, let me delete it. This one is positive 1. Tapos i-plus mo siya and then we are looking for the chlorine. Plus ito, 4 na atom si oxygen and then we know that oxygen is negative 2. And then this is equal to 0 because remember when you say compound, that the sum of all positive and negative charges will be always equal to 0. So i-simplify natin siya. This is 1 plus chlorine plus negative 8 equals 0. We can actually combine these two. Negative 8 plus 1, positive 1 is negative 7 plus chlorine is equal to 0. And then let's transpose the negative 7. Pag addition and subtraction, we do the transposition, it will become positive 7. Therefore, in this case, chlorine is positive 7. Ayan siguro yung tinatanong ni Laika na merong nakalagay na pwedeng positive 5, positive 7. mangyayari lang yan siya class pag chlorine and the other elements are involved in polyatomic ions. Pero pag hindi, -1 talaga yan si chlorine. Okay? Pag nasa parenthesis, yes, automatic. Kung ano yung subscript that will be the counting of the elements. Okay? In terms of the number of atoms. So another example will be wait lang, let me think. Example, magnesium phosphate. Oops, this is 3. Okay. Example, magnesium phosphate. Pag pina-compute kayo ng molecular weight, you have here the magnesium, the phosphorus, and the oxygen. When you count the number of atoms, syempre magnesium is 3. For phosphorus, this is inside the parenthesis and then you have the subscript outside na 2, so automatic that's 2. But for oxygen, you have to multiply that class 2 times 4, a total of 8. That's how you do the computation for the molecular weight if there are elements inside the open and closed parenthesis. Anything else that you would like to clarify? Napabay na nalibog? Ba? I did not actually dwell that much sa statistics since we don't really compute that in the board exam. That's just for the sake of the analysis, especially when you do research or assay in the laboratory and then you will do replicates or trials. That's just checking whether our values or data obtained are precise or not. So that is the reason again why I did not really focus on the statistics na side. But in here, I really need to establish the computation of concentrations of our solution because that is actually the work, the responsibility of a QC analyst in the lab. Most of the time, we will be asked to determine the concentration of samples or chemical substances in the laboratory. And this is just the first step. We really need to know how to compute the molar mass. And then the equivalent weight and the milli-equivalent weights are used to compute for the normality. If you have observed when you had your face-to-face class 2 years ago, I don't know if you had observed this, but the chemicals in the laboratory are labeled with a number and then followed by the name of the chemical. So just like nakalagay sa bottle 0.1 NHCl. So this is the name of the chemical, but this one is the concentration. Okay, so this is 0.1 normal hydrochloric acid. And ito yung hahanapin natin class, pagtutuunan natin ng pansin as we go on with the QC. Okay? So ito yung parating, I don't know if you can still remember si Sir Marlon dati, ito yung parating niyang nilalapit sa akin since he was the laboratory in charge at that time. And yung mga chemicals na ginagamit natin sa laboratory nagva-vary in concentration. Like parehas silang hydrochloric acid but one teacher would request 0.1 N, another teacher will request 2 N HCl. So yan yung parating niyang tinatanong how to make those chemicals with certain concentration. Kailangan mo lang talaga siyang i-compute and then pwede natin siyang gawin in the lab. Okay, anything else? May pangutana. How about the the mga definition of terms here. Analyte ha, that's the sample itself or the component of the sample that we are investigating. Yung titrant, yan yung nilalagay natin inside a burette. And most of the time, the titrant will be of known concentration. Alam natin yung concentration niya. Okay? By the way, other name for analyte is titrand. I don't know if I have mentioned that one in the recorded video, but titrand ito, letter D, ito titrand. Do not be confused. Kaiba yan silang dalawa. And do not forget to add indicator sa sample natin kasi mahurot na lang nato atong titrand class, we will not reach the endpoint. We will not see change in the color of the solution if we have not added the indicator. Okay? So endpoint ang tawag kapag ka nag-change na siya ng color during titration, and it means you need to stop doing the titration na. Itong stoichiometric point, this is just a theoretical point, but we cannot really see it. We cannot observe it through our naked eye. It's just an estimation that equal amount of the titrant and the analyte has reacted already. Okay? So, yun. Anything else sa milli-equivalent and the equivalent? Meron pa bang itong i-ask before ta mag-continue? Yeah, analyte or titrand. Titrand, letter D. Let's have our rationalize quiz ninyo. Nag-multitask ba ako din? Equivalence point, not equivalent point. Equivalence. Okay, so this was your quiz. So the first question here, a solution used in titration that changes color if there is a change in the pH of the substance being analyzed. This is indicator, or you can answer indicators or acid-base indicator. They will be added in the solution to be titrated, and then mag-change yan sila ng color. And then compute for the equivalent and the milli-equivalent weights of the following. So the first one is copper bromide. Copper bromide class, copper is CuBr for bromide, and then let's check their charge. Since may nakalagay dyan 1, automatic copper will be positive 1. And then bromide is nasa group 7 in the periodic table, and it means that it has a charge of negative 1. Now if we add this is equal to 0, so no need to do the crisscross. You just combine the symbol. The correct chemical formula of copper 1 bromide is just CuBr. Okay, now before you compute for the equivalent and the milli-equivalent weight, you just have to compute for the molar mass. We only have 2 elements here, Cu and Br. Cu is 1 then si bromide, and then let's multiply each of them to their respective atomic weights. Kindly look at your periodic table and kindly give me the atomic weight of both elements, since I don't have a periodic table here. Okay, you can send a chat or you can unmute. Copper is, bakit magkaiba kayo? Copper is 64. Okay, 64. And then bromine is, okay, 80. And then we will just add this. 64 plus 80 class is 144. Do not forget the unit for the molar mass, that's grams per mole. Now, if we're going to compute for the equivalent weight, do not forget the unit. Equivalent weight is equal to the molar mass or the molecular weight divided by the F. So this is 144 grams per mole divided by our equivalence factor here, automatic, that is 1. Okay, 1 kasi copper is positive 1, bromine is negative 1. Now for the unit, I think I have given this. This is equivalent per mole. That's the unit of F for the equivalent weight. And then you have to cancel the mole. You will be left with grams per equivalent. So 144 divided by 1 is 144. The unit is grams per equivalent. So this is the correct answer for the first one. And then for the milli-equivalent weight, this is the same but meron lang tayong times 1,000 here. So this is still 144 grams per mole divided by 1 times 1,000, but this time the unit should be milli-equivalent per mole. You cancel the mole. This is 144 divided by 1,000 is 0.144 grams per MEQ. If you have rounded this off to 2 decimal places, I have no problem with that. 0.14. Okay lang din. Okay. Any question for the first one? Wala. Sige. So for the ferric hydroxide, ferric is positive 3, hydroxide is negative 1. If you're going to add this is not equal to 0. So you really have to do cross multiplication or crisscross here, and this will become Fe. You have to place the OH inside the open and closed parenthesis. Since it is read as hydroxide, it means it's a polyatomic ion. It's counted as one entity. So you really need to place it inside the open and closed parenthesis and just write the subscript outside. So this is the correct chemical formula. And then if we're going to compute for the molar mass, this is Fe, oxygen, and hydrogen. 1 atom for iron, 3 for oxygen, and then 3 for hydrogen. And then iron is 56, oxygen is 16, and then hydrogen is 1. So this is 56, 48, and 3. And then let's add. But this is 107 grams per mole. I hope you got the correct answer here for the molar mass. Because if you are already wrong with the molar mass, everything will be wrong also. Equivalent weight is equal to molar mass divided by F. So this is 107 grams per mole. What about our F here? Our Fe is positive 3, hydroxide is negative 1, but we need to multiply it to its subscript. 3 times negative 1 is negative 3. So definitely our F here is 3. So this is equivalent per mole. Cancel the mole. The correct answer here is 107 divided by 3. Kung 2 decimal places, 35.67 grams per equivalent. So this is the correct answer. Now, for the milli-equivalent weight, actually wala naman talagang, divide lang natin siya sa 1,000. So 107 grams per mole divided by 3 times 1,000. This will be MEQ per mole. Cancel the mole. So 107 divided by 3,000. This is 0. You can have 2 to 3 decimal places. It doesn't matter. I'll still accept that. 0.04 grams per milli equivalent. Okay. This is for the milli equivalent weight of our ferric hydroxide. Questions for number 2? Alin dyan yung hindi naintindihan? Or naintindihan naman na? Wala yung pangutana. So let's move on. Perchloric acid. Perchloric acid is HClO4. This one is an acid. What are we going to do? Let's compute for the molar mass. Nawala ko. Nag-multitask mo ko ba? Nag-paminaw ko sa lunggan. HClO. So 1 atom of hydrogen, 1 atom of chlorine, and 4 atoms of oxygen. So this is 1. This is 35. And then this is 16. 64. Or patakara ko compute. 16 times 4. Yeah, 64. So 64 plus 35 plus 1 is 100 grams per mole. And then for the equivalent weight, this is 100 grams per mole. Our F here, this one is an acid, perchloric acid. So 1 lang ang kanyang hydrogen. This is automatically 1. Cancel the mole. So this is 100 grams per equivalent. For milli-equivalent weight, it's the same thing, 100 grams per mole. And then this is 1 times 1,000 MEQ per mole. So cancel the mole. This is 100 divided by 1,000 is 0.1 grams per MEQ. And yung correct answers for the given sa quiz. May pangutan na. You can send your questions sa chat ha if ever you have one. Okay? A theoretical point wherein equal amount of the analyte and titrant have reacted, either you call this stoichiometric point, or you can call this equivalence point. Okay? Theoretical point lang kasi siya. We cannot observe it during the experiment. What we can observe during the experiment is the end point. And that is represented by the change of the color of the solution. Kung mali ang solving, 0. Depende. Depende. Pwede po na i-point sa ballpen, mga anak. I'll be checking that. Hindi naman totally 0. Pero mag-brown out. Okay. In titration, the solution added by means of a burette is called titrant. This is false. I think I mentioned this a while ago. Titrant is the other name for analyte, and that is the sample being assayed or analyzed during the process. Pag sinabing titrant, that is the one that is added by means of a burette. Okay? Titrant, dapat yon, letter T. Okay? We have to be careful. Okay? So that's it for our quiz. Any question? Yes.
Mama, sa kanyang titrand, itong D?
Titrand or titrand ha ka ng letter D ang ending, that is the other name for analyte. That is the other name for analyte class. That's the one being tested in the assay. And then titrant, the one that is added using a burette. I hope you watched the video of the titration process so para may picture kayo on what is how is it done. Pero since may face-to-face naman kayo na laboratory, feeling ko naman ipapagawa ito ni Ma'am. Ano teacher niyo? Si Ma'am Charm siguro, no? Feeling ko ipapagawa naman ito ni Ma'am Charm sa inyo yung titration. Brown out. Okay. Any other concern about the quiz? Sana. So, let's move on. This is still sa chapter 3. This is standardization. Class, when you hear the word standardization in the QC area, it means that our goal is to determine the concentration, the exact concentration of our solution. So that's any solution, as long as we are going to do a method that will give us the correct concentration of our solution. Okay. Wait. Okay. Now, in getting the concentration of our solution, standardization is done through titration. Again, this is done through titration, pag chemical analysis. Okay? Now, either we use a secondary standard here, pag sinabing secondary standard, this is a liquid sample and this is added through a burette. Therefore, it can be called our titrant. So yan yung ginagamit natin for titration. Okay? However, there are instances that we are going to use a primary standard. Okay? Ito naman ang tawag dito. No, the primary standard is a solid sample, a solid substance used during titration. So magiging baliktad sila. I don't know, yung binigay ko ata sa inyo na video is yung titration process ata yon ng sodium hydroxide solution. Meaning nun, the one that was conducting the experiment there was looking for the concentration of the NaOH solution. Pero I think ang ginamit doon is a primary standard. So, I think ang ginamit kasi doon is potassium acid phthalate. Ang ginawa kasi sa titration, itong potassium acid, sulat na kong tarong ha. Potassium acid phthalate. Ayan. Ito kasi siya is a solid substance. Actually, naka-powder ito. And then after that, i-add siya sa water, gagawin siyang solution. Tapos ilalagay siya sa Erlenmeyer flask. Tapos, magta-titrate ka using a burette. Siyempre, kay burette man dyan na itong ginagamit for titration. Pero magbabaliktad sila. Kasi nandito si primary standard, nandito si NaOH. So, baliktad sila. Si NaOH ngayon ang magiging titrant. Kasi again, this one is added via a burette. Pero actually, siya yung sample natin. Meaning, ito yung hinahanapan natin ng concentration. So, kailangan natin may identify during the titration process kung ano ang ginamit during the titration. Primary standard ba or secondary standard? So, again, in this case, this one is the titration process is done using a primary standard. You have there a solid sample, ginawang solution, nilagay sa burette, dinagdagan ng indicator, and then during the titration process, the analyte is added using the burette. So nagiging titrant din siya in the process. Pero if you have seen titration process na secondary standard ang ginamit, meron din kasi example NaOH pa rin na solution. Tapos ang gagawin, you have the burette here. Yung NaOH solution is placed here in the Erlenmeyer flask together with the indicator. Tapos ang ginamit na titrant is the hydrochloric acid. So ito, since hydrochloric acid is a liquid sample and it is added using a burette, naging titrant siya, ang tawag sa kanya is secondary standard. I hope ma-differentiate nyo na siya by this time. Pero the process is still standardization because our goal is to determine, identify the exact concentration of our solution. So na-mention ko na to kanina, primary standard is a solid substance used during standardization process. It's a solid one. Pero if you use a solution of known concentration, meaning it's a liquid, during the process to identify the concentration of your sample, then we call that secondary standard. Now, we have a lot of secondary standard actually, but we have a limited number of primary standard. Because when you say primary standard, it has to meet the following requirements or criteria. So number one, it has to be very pure. Mga 99.9% pure siya. Like yung ginamit for the standardization of sodium hydroxide, the potassium acid phthalate, it should be very pure. It should be made up of 99.9% potassium acid phthalate. Okay? And then, syempre, definite and known concentration and not affected by drying. So even if before the process of the titration, magda-dry ka ng sample mo, dapat si primary standard will not be affected. And at the same time, soluble in water because as I have mentioned a while ago, the potassium acid phthalate was dissolved in water and then naging solution siya, nilagay siya sa Erlenmeyer flask. Okay? So we have here examples of primary standards that can be used in the standardization of sodium hydroxide. Kasi natingala mo, pirmi lang ko nagaingon ng sodium hydroxide. Kasi in laboratory class, NaOH is a very commonly used chemical substance. So since marami siyang gamit, before siya gagamitin, kailangan i-standardize muna siya. Meaning, kailangan mo nang ma-identify yung kanyang exact concentration. Kasi si sodium hydroxide is not really that stable. And this is actually hygroscopic. When you hear the word hygroscopic, remember it means that any substance that absorbs moisture in air. So if you are going to place your sodium hydroxide in a table and then you don't have a closure, meaning walang takip, most likely absorb niya yung water sa air and mag-iiba ang kanyang concentration kasi may nadagdag na water. Kailangan siyang parate i-standardize. So ito yung mga examples of the primary standard we use for sodium hydroxide. The most common one is the potassium acid phthalate. Below you can see the chemical formula. C6H4COOK-COOH. Yan yung kanyang chemical formula. However, if potassium acid phthalate is not really available in the laboratory, we can use either the sulfamic acid, benzoic acid, or the potassium acid iodate. All of them are solid substances, so they are considered primary standards. Okay? Questions so far? Kung na-confuse kayo, pakibalikan, watch yung titration process video na nilagay ko, sinend ko yung link sa Schoology. Okay, now since our goal sa QC for standardization is to determine the exact concentration of our solution, then kailangan natin ma-identify anong unit yung ating gagamitin. So you can either see normality, molarity, or percentage. Actually, meron pang iba, pero ito yung pinaka-ginagamit natin in the lab. Actually, meron pa yan siyang molality. We also have the ppm and we also have the ppb. ppm is parts per million and ppb is parts per billion. So let's concentrate first here sa normality. Normality is, ang symbol niya is capital letter N. So you can see this in the label. For example, hydrochloric acid, meron nakalagay 1NHCl. The 1N there is the concentration. So for molarity naman, that's capital letter M. Do not be confused between the two. Kung nakalagay M, 1MHCl, ito yung concentration niya. But they are different units of concentration. The other one is normality. This one is molarity. And I think ito yung pinaka-common sa inyo percentage. Pag sinabing 100% HCl, meaning this is very pure hydrochloric acid kasi 100% talaga siya. Or kung in the case of alcohol, we have a lot of that in the market. Like nakalagay 70% ethyl alcohol. So concentration niya yun. 70% is ethyl alcohol. The remaining 30% will be for the other additives like water. So yan yung ibig sabihin ng percentage. Pero kung normality and molarity, ibang usapan yun siya. And then we are going to compute for that. Okay? Now let's have, wait lang ha. Hindi pala ako nagbigay. That is the dilemma of Ma'am Cherry last year when she was tasked to be the teacher of QC. Siya yung QC ng 4th year dati. Tapos, nangayo naman siya sa kuwag slides. Gihatag ko na ko tanan akong slides sa iya ha. Nga, nag-struggle siya kay wala ko'y examples. Wala siya ko naghatag og like examples on my slides class. Please bear with me kasi hindi talaga ako yung nagpe-prepare talaga ng slides na with all the examples. Nag-on the spot kasi ako nagbibigay ako ng examples pero that will be on the spot. Like normality, tapos computation sa normality. I make my own problem. I make my own problem and good and then answer that on the spot also. So I want man good na pag nag-solve ko step by step process. Di ko gusto magsige click-click sa ako ang laptop para ihatag din haang iyahang process. Gusto na ako magod ginasulat. So you really have to listen sa ako ang klase kay kung magsalig mo sa ako ang PowerPoint tapos example hindi ko nabigay yung what you call that, yung recording, maglisod jud mo parehas ani. You have here the normality, I have given here the formula, and that's it. Meaning I'll just give an example later. And that's the same thing with the molarity also. Okay? So again, please listen kay magsugod na ta sa ato ang computation. This is the first one, the normality. So this is the first unit of concentration. Again, we call this normality, and the symbol for this is capital letter M, but we can also use units like equivalent per liter or milli-equivalent per ml. So the definition of normality is actually the number of equivalent of our solute in 1 liter of our solution. So that is the reason why before we proceed in the computation of the concentrations, we first discussed the equivalent and the milli-equivalent weights. We need them in the computation of normality. Again, when you say normality, number of equivalent sa solute in a liter of solution. So in the computation class, we will be using these formulas. Depende. We have two. Number one, normality is equal to weight in grams divided by volume in ml. Take note in ml. Kasi pag ml yung given na volume, you will be using the milli-equivalent weight. Okay? But if in the problem, the given is in liters, you will be using the equivalent weight. Okay? So, paki-take note ana para dili malibog. So, let me na-close. Balik. Let me give you an example. Okay. Just like this problem. Number 1. What is the concentration in normality of the prepared 1,500 ml of 0.9 grams sodium hydroxide. So, ganito yung mga problems mostly sa board exam. Pinapa-compute sa inyo ang normality. So, please read the problem and try to understand the problem class. Ang nakalagay dyan, i-compute mo daw yung concentration in normality sa prepared na solution. So, anong ginawa sa solution? Merong 0.9 grams na NaOH, and then dinisolve sa water, and then yung volume niya, ang total is 1,500 ml. So, hindi naman talaga mahirap gumawa ng solution sa laboratory. Just like when you do salt solution sa kitchen ninyo, na magkuha lang mong asin, gitunaw ninyo sa water. Ana lang po dato mga chemicals sa lab. If we have powdered chemicals, solid chemicals, if we want to make a solution, you just add water, stir it until all the particles are dissolved. But in this case, we are really looking into the concentration of the prepared solution. So ito yung given natin. Okay? Nasundan pa, tell me ha kung masyado akong mabilis. So, our formula to be used here, again, weight of the sample, this should be in grams, divided by, take note that the volume given is in ml. So you have to also use the formula na naka-ml din. So this is volume in ml. And remember, ang partner ni ml is the milli-equivalent weight. Okay, so this will be our formula. Now, substituting this, you have weight in grams, that's 0.9 grams of NaOH, volume dissolved in 1,500 ml. And then, i-multiply siya sa milli-equivalent weight. Now, the milli-equivalent weight is not given in the problem. It is your task to compute for it. So you have to go back with our previous lesson. Milli-equivalent weight is equal to the molar mass divided by Bf times 1,000. Pero wala pa tayong molar mass dyan. Hindi din siya binigay sa problem. So you also have to compute. So, mo ni siyang ginaingon nga scam pag moingon kag walay math sa pharma. So, daghan kayo taong. Daghan kayo tag computations from your pharm calc class, and then we have here the QC. Pag QC computations talaga yan siya. So, let's continue. We have one atom of sodium, one for oxygen, one for hydrogen. Multiply each of them to their respective atomic weights. Let's just use whole number para uniform tayo lahat. Ay, ano nilagay ko? Ay, 1,000, sorry. Kulang og 0. F times 1,000. Okay, so this is 23. So this is 23 also. Oxygen is 16. And then hydrogen is 1, 23. This is 40 grams per mole. So this is the molar mass now of our sodium hydroxide. 40 grams per mole divided by the F. This one is a base and it only has one hydroxide. So automatically the F is 1 times 1,000. Remember our unit, this is MEQ weight, so this is MEQ per mole. Okay, cancel the mole. This is 40 divided by 1,000 is 0.04 grams per MEQ. So we have now the molar mass. Ilagay natin, MEQ weight eh. We have now the MEQ weight. So ilagay natin siya dito, 0.04 grams per MEQ. Okay? So we can cancel actually the grams and take note no maiiwan na unit. This is 0.9. Step by step natin. 1,500 times 0.04 is 60. Ang naiwan na unit? ml. And then this is per MEQ. Okay? Yan yung naiwan na unit. And then let's continue here. 0.9 divided by 60. This is 0.015, or you can round this off to 2 decimal places. Pag mag-quiz tayo or mag-exam, paki-ano na lang, paki-follow yung instruction kung paano nyo i-round off yung final answer. Now, what is the unit? Ang unit na to class is MEQ per, sorry. Ano or? Get so excited. MEQ per ml, or you can write 0.015 capital letter M. So, basig natingala mo, ma'am, ml per MEQ man na dinhi. Nganong pag-abot sa answer, MEQ per ml. This is our rule sa mathematics. If you have a units na nasa baba, tapos naka-per, or naka, like, merong like division or ml per MEQ, Sa kagaya sa example dito, pag dinivide mo siya, you have to get the reciprocal. Diba when you say reciprocal, kailangan siyang baliktarin. So this is MEQ per ml. Okay? Pero MEQ per ml is equivalent to capital letter N. So this is now the concentration of the prepared solution of the sodium hydroxide. So pag after anig prepare sa iha class, pwede na siya i-label 0.015 N NaOH. So pwede mo na ito ilagay sa label. That's how you compute for the concentration in normality of the prepared solution. Questions? Oras na. Still have 1 hour. Questions? Anyone? Kung wala question, mag-ano din ko. Tagal na. Mag-assume jud ko nagkasinabot ta ani tanan. Mag-assume ko nga kasinabot pag-abot sa quiz o sa exam. Wala dito nagkasinabot. Ang final answer, depende. Minsan kasi pag nag-quiz ako or nag-exam, minsan hinihingi ko 4 decimal places, minsan 2 decimal places, and that's the importance of following instructions. So you really have to be careful. You have to really read and understand the instructions during the quiz or the exam. Sige na may gusto ipangutan na wala. Sige. I'll give you another example. This time, you have to compute that in your own extra sheet of paper there, and kindly send your answer sa chat. I-private message sa akin, and then I will count that as your recitation. This is problem number 2. Let me think of a problem first. Ma'am, example sa lab is 0.5 NaOH available pero need ng teacher is 0. Yeah, pwede yan siya gawin. Mag-calculate din. I'll teach you later. Sige, humanin sa natin. Tuluan tamuan ng sa himuon na ng ingana na problem. Compute for the normality mahang ko. Gusto ko. Okay? Sige. Ay, hindi dapat na siya question mark. Ayan. Compute for the normality of a solution prepared by dissolving 1.5 grams calcium chloride in 2,800 ml solution. I'll wait for your answers. Paki-send sa private message dito sa chat.
Copy and answer pa to siya, ma'am.
No need na. Pwede po ninyo siya kapihon para you have a copy of the problem. Pag may question mark, meaning dili sure. Four decimal places. Lahilig mo answer. Kindly recheck your process if you have missed something. Kay lahi mong answer. Saka tinuod din na. I actually don't know what the answer is. I remember I just made this here on the spot. eh. Ano naman na yung question mo? Okay, sige. Let's answer. Let's answer this. So, if we try to understand the problem, the solution that is formulated here is 1.5 grams of calcium chloride dissolved. Calcium chloride plus is CaCl2. CaCl2 yan ha. Ca positive 2, chlorine negative 1. So you need to do crisscross here, which means the correct answer is CaCl2. Okay? So CaCl2 dissolved in 2,800 ml of our solution. So we will use this same formula. Normality is equal to weight in grams divided by volume in ml times the milli equivalent weight. So milli equivalent weight ang partner ni ml ha. Sige. So the weight here is 1.5 grams. The volume is 2,800 ml. And we have to compute for the milli equivalent weight. But before we can compute for the MEQ weight, we have to compute for the molar mass first. Ca and Cl. So 1 atom for calcium, 2 for chlorine. This is 40. Kindly check kasi nagpataka lang ko. I don't have a predictable here. And then chlorine is 35. So this is 70. This is a total of 110 grams per mole. Now, if we have the molar mass, we can compute for the MEQ. MEQ weight. So this is molar mass divided by F times 1,000. Excuse me. So this is molar mass is 110 grams per mole. And this is not an acid. This is also not a base. So you will be looking at the charge. Calcium class, remember, is positive 2. Chlorine is negative 1, but you have a subscript of 2 here. So this is negative 2. 2 times negative 1. So parehas na silang 2, which means our F here should be 2. I hope you got the correct answer. Okay, and then our unit is MEQ per mole. Cancel the mole. This is 110 divided by 2,000 is 0.055 grams per MEQ. Please do not round off during the process, just round off during the final answer. So 0.055 grams per MEQ. Cancel the grams. We will have here 1.5 divided by 2,800 times 0.055 is 154 ml per MEQ. Let's divide this. 1.5 divided by 154 is 0.0097. Sabi ko kanina 4 decimal places. 1, 2, 3. Yeah. 0.097. And then let's get the reciprocal. This is MEQ per ml. Or you can simply write 0.097 and then capital letter M. So this is the correct answer. Sabi ni mo 1.15 grams, 1.5. That's 1.5. So let's check who got the correct answer. Okay, tama. Okay lang itong 0.009, no problem. So, anyway, most of you got the correct answer. I hope those na hindi nakuha yung 0.009 or 0.0097 is na-identify nyo saan sa process kayo nagkamali. Okay? Okay. And then, mali ang rounding off sa atomic weight. So, nearest whole number tayo. That's 35 for the chlorine. And then for the F, that is 2. Dapat 2 yan. Kasi calcium chloride. So, marami tayong dapat isipin kapag ka nag-compute tayo for the normality. Alam mo, 1,500 grams? 1.5 grams lang yan siya. 1.5 grams lang dapat. Layo na tayo siya. Now, I'll give you another set of problem. Later na yung question ni ano ka? Sino yung nag-ask? Basta I'll teach you how to do that later. Pero ito muna. Kasi nangyayari din ito sa laboratory. A new compound. Okay, this is another type of problem. Baliktad ito, class. Ang hinahanap, how many grams of sodium chloride yung kailangan para makagawa ka ng 2.5 liters of 0.05 normal NaCl solution. Okay? So, baliktad siya. Kasi yung two problems a while ago, yung hinahanap natin concentration. So gumawa na ng solution. Alam na yung grams, tas dinisolve na lang sa solvent to make the volume of the solution. This time nangyayari talaga ito sa laboratory, like if you're going to work in a QC area, the QC analyst or the QC supervisor may ask you to prepare a solution, tas ang ibibigay niya lang is ang volume and ang concentration. So you have to look for the grams of the substance na gagamitin mo para mabuo mo yung solution mo. Okay? So again, how many grams of sodium chloride is needed to make 2.5 liters of 0.05 normal sodium chloride solution? Convert pa liters to ml. You have the option na i-convert si liters to ml, but you also have the option, remember, na meron tayong formula na naka-liters talaga siya. Pero ang partner ni liters is equivalent weight. So pwede nyo din gamitin yon. What are we going to do here? Yung given natin, 2.5 liters daw of the 0.05 normal NaCl solution. So what is asked here is the amount in grams. If you are like not into derivation of the formula, kay malibog mo sa pag-derive sa formula, just go back with the original formula and just substitute everything. Okay? Ako, personally, I'm not a fan of formula derivation. Mas gusto na ako maggamit o kaning normal na formula, original formula, and then I'll just substitute everything and do the computation. So this one is weight in grams divided by, again, it's 2.5 liters. 2.5 liters yan. Okay. Now, di ba, we have a formula na volume in liters. So, pwede na kayong hindi mag-convert. Pero kung gusto mo mag-convert, wala pa na siya problema. Pero ang partner ni volume in liter is equivalent weight. So equivalent weight yung gagamitin natin dyan. So ako, again, personally, I don't derive formula. I just substitute everything. Pero kung mag-derive ka, ano mo lang man ito, cross multiply mo siya. Baba mo si weight and then just multiply everything. Normality times volume times equivalent weight. But anyway, I'll just write 0.05 n here, but I will not use the n na capital letter N kasi hindi natin makikita yung cancellation of the units kung n yung gagamitin ko. Balikan natin yung units ng ating normality. Pwede siyang equivalent per liter, pwede din siyang MEQ per ml. So, since I'll be using liters and equivalent weight here, I'll be using equivalent per liter na for a unit here para madaling i-cancel. And then we are looking for the weight in grams. For the volume, it's given 2.5 liters and then i-multiply natin siya sa equivalent weight. Okay. Now, sorry. Saan na pa? Equivalent weight. Molar mass muna tayo. This is NaCl. So Na and Cl, 1 atom each, times their respective atomic weights in whole number. This is 23, this is 35. So all in all, this is 58 grams per mole. Okay, now, equivalent weight. Equivalent weight is equal to molar mass divided by the F. So, ang molar mass that is computed is 58 grams per mole divided by our F. This is NaCl, so salt, automatic. But if we are going to look at their charge, sodium is positive 1, chlorine is negative 1. Walang subscript, so automatic this is 1. Okay? So, ang atang unit, equivalent per mole. Since we are using equivalent weight here. Cancel the mole. This is 58 grams per equivalent. So, again, this is 58 grams per equivalent here. Actually, anong ginagawa ko here? Nagko-cross multiply pa rin naman. Binababa ko yan si weight of grams. Tapos, imumultiply mo ang lahat. 0.05 equivalent per liter times 2.5 liters times 58 grams per equivalent. Cancel the equivalent, cancel the liters. Ang maiiwan na unit ay grams. Okay? Dito na ko sulat. This is 0.05 times 2.5 times 58. The answer here is 7.5 grams of the NaCl. So, eto na ngayon. Alam na natin kung gaano karaming sodium chloride ang needed na i-dissolve para maging ano siya, ang kanyang concentration is 0.05 normal, tas ang volume niya is 2.5. Okay? So, sa laboratory class, if you are asked by your teacher to prepare a solution, tapos ibibigay niya yung amount in volume and also ang concentration, tapos the concentration is in normality, ganito ang gagawin ninyo. You have to compute for the weight of the substance. Okay? The process is just ang 58 divided by 58 divided by 1,000 po, di ba? That is true if we are computing the milli-equivalent weight. Nakuha to? That is true. 58 divided by 1,000 if milli-equivalent weight ang kinocompute natin. Pero I'm using the equivalent weight man here. Kasi liters man ang given na volume. If mag-solve, need ito sundin na format? No. Actually, you don't need to to copy my process. If gusto niyo i-shortcut, wala akong problema with that. As long as parehas tag-answer. Kung gusto ninyo mag-derive of formula first before ninyo siya i-compute, no problem with that. Nga nilang dyan mag-solve. Then, remember sa mathematics, manggod, pwede manggod lahi-lahi tag-solution, basta parehas tag-answer. Basta tama ito ang answer. So, I'm not really that strict na ganyan talaga ang pagkakasunod-sunod ng pag-compute. Pag grams, milli equivalent weight, no. Grams talaga yung ano natin, yung amount ng substance natin. Nakadepende class sa volume. So, tingnan nyo ang volume. If liters ang binigay, you use the equivalent weight. Pero pag ml ang binigay, you use the milli equivalent weight. Ay, 7.25 di ay, sorry, nabilin ang 2. 7.25 grams of NaCl. Okay, anything else? Wala na ba? Let's go back to the question of what's that again? Balikan sana ko 0.5 tas ang 0.5 ang available pero need sa teacher 0.2. Okay. Let me give you a sample problem of this. For example, number 3. Ito na lang gamitin ko yan. If for example, you have an available of 0.5 normal NaOH solution, meron kang, for example, 100 ml of this. Ayan. Again, you have 100 ml of this. Tapos, ang need ng teacher, 0.2 NaOH lang. So, ano daw yung gagawin? Kapag ganyan class ang scenario, ganyan ang situation sa lab na meron ka namang sodium hydroxide na solution, iba nga lang ang concentration, kailangan mo ng ibang concentration, ang process nito dilution. Bakit dilution? Kasi from 0.5 naging 0.2, bumaba yung kanyang concentration. So pag if you encounter this kind of scenario or problem, pag dilution gani ang atong formulaan na always na siya C1V1 equals C2V2. Wherein C1 is your concentration for the original solution, yung at hand or available solution mo. And then the volume, V1 is the volume of that original concentration or original solution. C2 is ito yung hinahanap natin or ito yung required solution. And then kailangan mo din ng volume niya. Okay? So, i-substitute mo lang siya dyan, class. The original solution, ang concentration niya, 0.5 N. Tapos, ang available niya na volume is 100 ml. Tapos, ang kailangan mo, 0.2 N. Meaning, we will be computing for the V2 here. I'll teach you the process later after natin makompute ang V2. So, isolve mo lang. 100 times 0.5 is 50. N times ml, this is times, kay multiplication man na silang duha, 0.2 N times V2. And then since this is multiplication, we don't do transposition here. Instead, we divide both sides with the 0.02 N to isolate the V2 there. Hindi ko na siya baliktarin ha, dyan na si V2. 50 divided by 0.02 is 2,500 ml. Okay, you cancel the the normality. So you will be left with 2,500 ml na volume. So ang pangutana, unsa una siya, ma'am? Sa laboratory, ganito ang ginagawa natin. So di ba we have 0.5 N na 100 ml. Tapos ang kailangan natin 0.2 N. So ang ginagawa, class, you just add solvent. Most of the time, our solvent, water, up to maging 2,500 ml siya. Okay? I-add mo doon sa original solution mo yung water hanggang maging 2,500 ml yung kanyang volume. Automatic, ang kanyang concentration will be 0.2 N. That's how we do it in the laboratory. Kung hindi grams yung available ha, walang solid material, walang solid na sodium hydroxide. Instead, meron tayong nakasolution na siya daan, pero lahi iyahang concentration. So kung lower na concentration ang atong kailangan, the process is dilution. So our formula again is C1V1 equals C2V2. And then we are computing for the volume here. Tapos pag na-compute mo na ang volume, kung sa laboratory pa ito, mag-a-add ka lang ng water doon sa original solution mo hanggang maging 2,500 ml yung solution niya. I'm not saying na 2,500 ml inyuhang i-add nga tubig ha, dili. Magkuha ka og volumetric flask na 2,500 ml, ibutang nimo ng 100 ml sa sulod, tapos you add water hanggang maging 2,500 ml ang kanyang volume. I hope that is clear. And then automatic, yung concentration niya is 0.2 N. Okay? Nasabtan to siya or did I answer your question? Si Charda ito. Philip?
Yes po.
Okay. Pwede po na ninyo siya himuon sa inyong mga balay. Gusto ninyo mudaghan inyong alcohol. Ay, 0. Lagi-erase na hinuon ako. Ito tawag isulat 0.2.
Opo, ma'am.
Ito dito akong originally gisulat 0.5 N, 100 ml, tapos 0.2 N, no? Ito akong isulat
Yes, ma'am.
0.02.
0.02, ma'am.
Ulit na to. This should be 0.2 N. 0.02 akong gisulat. Cancel this, cancel the N, the V2 here. 0.5 divided by 100, 0.5 times 100 divided by 0.2. Ay. $250 lang na ito. Nga naman to. Kindly correct if nag-copy kayo. That should be 250. Ginugangan akong isa ka 0 kagaya na. Pero originally, 0.2 N pala yung given. So 250 ml lang siya. From 100 ml, you add enough water until the volume becomes 250 ml. This is a dilution process. When you say dilution, you are making a new solution with lower concentration. Yan yung dilution process. So again, sa inyong mga balay, pwede ninyo na siya himuon. Example, bumili kayo ng 70% ethyl alcohol. This is not normality, pero concentration yapon and then process sa dilution. So ito mostly yung benta sa 'di ba? Pero may 40% din tayo. Pero kung 70% tapos 500 ml yun siya, tapos gusto niyo dumami yung alcohol ninyo pero effective pa rin. Ang effective na pinakamababa natin is 40%. So kung gusto niyong gawin ito class, mag C1V1 gihapon mo. C1V1 equals C2V2. So yung C1 originally 70% yan siya. Ang volume ng binili mo 500 ml. Gusto mo dumami siya pero effective pa rin, so 40%. Tapos we will be computing for the volume number 2. 70 times 500 is 35,000% times ml. This is 40% here times the V2. Divide both sides with the 40%. Cancel this, cancel the percent. 3,500 divided by 40. The V2 is 875 ml. So ang gagawin mo, yung 500 ml mo na alcohol, dagdagan mo ng tubig hanggang maging 875 ml na siya. Tapos automatic, ang kanyang concentration yan ay 40%. So dumami na yung alcohol mo, pero again, effective pa rin naman siya. That's the process of dilution. Ibang unit lang ng concentration ang ginamit ko ha, kasi yung pinaka-common na ginagamit natin sa household, sa bahay. Okay? Questions so far? Questions daghan gito ba? Or clarification? Wala? Sure na? Okay. Again, this is molarity. This is M sa as symbol niya, but this can be moles per liter also. Kasi by definition, molarity means number of moles of solute per liter of solution. Class moles is our SI unit, our international standard unit for the amount of substance. And in molarity, we are determining the number of moles of solute being dissolved in a liter of solution. Therefore, the formula for our molarity is capital letter M is equal to moles of the solute divided by liters of solution. However, in the laboratory, we don't really have an equipment or an instrument that can measure the moles. So most of the time, most likely, we measure our substance, especially if it is solid, using analytical balance. So weight talaga in grams ang makukuha natin. Excuse me. So before you can proceed with the computation of molarity, you will be asked to convert first moles into weight of the substance, into moles. And this is our formula, yung second formula na nasa baba. Weight of the substance divided by its molecular weight, or molecular weight is another term for molar mass. So just like the computation of normality, we also need the molar mass here. So let me now give you an example. Let me write the example on the screen. Okay, what is the concentration in molarity of a solution formulated by dissolving 2.5 grams of sodium bicarbonate in 1,500 ml solution? Okay. So anong gagawin? Let's go back to the formula. Molarity is equal to moles per liter. Yan yung hinahanap, molarity ng ating solution, concentration niya. Pero paano ba ginawa ang solution? Gumamit ng 2.5 grams of sodium bicarb, dinisolve in 1,500 ml na solution. So sabi ko kanina, you cannot proceed with the computation of the molarity if you will not convert 2.5 grams into moles. So you have to use the second formula. Mole is equal to the weight of the substance in grams divided by its molecular weight or molar mass. Now this is molar mass. Now the weight of the substance is 2.5 grams. And what is our substance? Sodium bicarb. So you have to compute first for the molar mass, NaH and CO. 1 for sodium, 1 for hydrogen. Carbon is also 1. And oxygen is 3. Okay? And then sodium is 23. This is 1, 12, and 16. So 48, 12, 1, and 23. So this is 84. Tama? Wait lang. Basig na tayo trust issues. 48 plus 12 plus 1 plus 23. Yes. 84. Okay, basig pataka lang ko agad. 84 grams per mole. Okay, cancel the grams. You will be left with a mole. Per mole actually siya, pero if you divide that, you will get the reciprocal. So mole pa rin yung kanyang unit. 2.5 divided by 84. Again, please do not round off during the process. Just round off the final answer. So we have to be patient with a lot of numbers here. 0.02. 9761904 mole. Ayan. Mole or mole. By the way, the name is mole, but the symbol is mole without an E. So parehas lang yan sila ha. So meron na tayong moles class 0.02976 1904 mole divided by the volume is 1,500 ml. But take note that molarity only uses liters. So do not forget to convert. 1,500 ml. What is our conversion factor? ML sa baba para makancel yan. So liters ang sa taas. And do not forget, 1 liter is equivalent to 1,000 ml. So this is 1.5 liters. Yan yung i-divide natin dito. So 0.029761904 mole divided by 1.5. Let's round it off to 2 decimal places. The answer is 0.02 mole per liter, or you can simply write this as 0.02 and then capital letter M. Pwede mo din idugtong yung name ng solution. Ito yung concentration ngayon ni sodium bicarb solution, 0.02 molar. Kapag nag-dissolve ka ng 2.5 grams of sodium bicarb in 1,500 ml. Questions about this? Actually, mas complicated si normality kesa kay molarity. Mas madali itong molarity class, magko-compute ka lang ng molar mass, i-convert mo lang si weight in grams into mole, and then divide ka na. Especially if the volume is in liters already, divide ka na diretso. Pero pag hindi, convert ka lang din ng ml to liters. Questions or clarification? Oras na. Wala? The C1V1 equals C2V2 is also applicable for molarity. If you are going to do the dilution process, pwede din yun siya. Okay? Let me give you another example. You are going to do the computation, ha? Molarity. I want new substance. So again, in molarity, we don't need the F, the equivalence factor. We don't need to compute the equivalent and the milli-equivalent weights. Diretso na. Okay? Kindly send your answers sa private chat para ma-record yung inyong recitation. Then, what is the concentration in molarity of 3,850 ml solution made by dissolving 2.9 grams of magnesium chloride? Excuse me. Uy, lahilig mo answer. Kindly check. Question mark. Hindi mo sigurado sa inyong answer. But since it's almost time, ito na. Ito na lahat yung mag-send. Again, molarity is equal to moles per liter. So, yung moles, compute muna natin siya. Moles is equal to the weight of the sample in grams divided by its molar mass. Ang given dyan, 2.9 grams. Yung molar mass, magnesium and chloride, hindi ko alam ang atomic weight ni magnesium. Kindly send. Yun sa ang atomic
24, ma'am.
24?
24, ma'am.
Oh, okay, 24. So this is 24. Ay. Manaan. 24. And then this is 2 times 35. So this is 70. This is 94 grams per mole. 94 grams per mole. Cancel the grams. So 2.9. 2.9 divided by 94 is 0.03085 mole. So, lagay natin siya dito, 0.0308. Signalibat ko, 51063 mole divided by liter of solution. The given is 3,850 ml. So, you need to convert this first. Okay? Cancel the ml. 3,850 divided by 1,000 is 3.85 liters. So, ilagay natin siya dito. So, 0.030851063 divided by 3.85 is 0.000123. 8. Pwede din, lagyan nyo pa ng 1. Pero okay lang din 3 decimal places. Moles per liter or 0.008 capital letter M. Pwede din lagyan pa ng 1. So, no problem. Wala naman akong sinabing ilang decimal places. But this one is the answer. Okay, 0.0008 or 0.0081. Okay, ito yung ating sagot. Yan yung molarity. Masyadong mababa yung concentration ng prepared solution. Konti lang din kasi 2.9 grams lang ng magnesium chloride and medyo marami yung volume, 3,850. So we will really expect a lower concentration, 0.0081. So I hope by now, alam nyo na paano isolve ang molarity. So dalawa na yon, molarity and normality. Do you have questions before tayo mag-end? Hanggang dito ang coverage ng ating prelim exam next week. Actually, that is the last slide also. Questions or clarifications? Wala. Sure na.